This is a nanoparticle. This is a $1 coin. If this nanoparticle was the size of a $1 coin, the coin would be the size of a Death Star. Alternatively, returning to our coin, cut it in half, cut it in half, cut it in half, cut it in half. And now you have a nanoparticle. So, back to our nanoparticle. There's a particle measured on the nanoscale. That's 1 billionth of a meter. Nanoparticles are currently an area of intense scientific focus, possibly because at the nanoscale, particles exhibit unique and exotic properties. For example, to us, gold is yellow and shiny, but on the nanoscale, it's red and purple and clumps together like bits of hair. Operating on this scale allows nanoparticles to interact in interesting and unexpected ways, making them invaluable to both medicine and technology. Nanoparticles date back to the Mesopotamians in glazed pots that glittered in the sun. Gold and copper ions reacted with oxides and at high temperatures covered these pots with a glittering film. Fast forward 1,000 years to Michael Faraday, who in 1857 gave a scientific explanation of the glitter phenomenon, nanoparticles. A century later, Richard Feynman produced a lecture discussing the use of electron beam lithography, i.e. printing, to make patterns in nanoparticle films which could then be connected to create circuits, the integrated circuit. Arguably the most important invention of the modern age, integrated circuits have revolutionized modern technology and are found in all digital appliances. Computers, televisions, cars, phones, iPads, CD players, you name it. Taking further strides in nanoengineering, buckyball was discovered in 1985 and rapidly became the interest of the brightest scientific minds, opening up research into fullerenes. To elaborate, the most common fullerene is the carbon nanotube and can be visualized as a tube of chicken wire but 100 times stronger. Fullerenes have been found to possess incredible electrical resistivity and heat tolerance and can already be found in paints, tennis rackets, and bicycles. For any who doubt nanotechnology's ability to drive humanity into the future, research is being conducted into the construction of a massive space elevator using fullerene cables, establishing humanity as a cosmic species. It certainly would make bombing extraterrestrial planets easier. Mind you, the last people that tried that. Circling back to the present, the main use of nanoparticles today is in cosmetics, perhaps most notably in sunscreen. Brands such as L'Oreal, Christian Dior, and Yves Saint Laurent have all used nanotechnology to deliver cosmetic compounds deeper into the skin, increasing their effectiveness. This is especially used for moisturizers and wrinkle removers to finally give you that fresh, youthful look you've been looking for. In sunscreen, zinc and titanium oxides filter out harmful UV radiation and prevent cancerous growth. Nivea and Unilever originally developed nanoparticles to make sunscreen more aesthetically pleasing, but are now found universally at increasing SPF or sun protection factor, in addition to any aesthetic contributions. Nanoparticles can be engineered to have very specific properties, making directing them possible, an outcome that has opened avenues in medical research. Nerve, spinal injuries, and cancer treatments are examples of medical nanotechnology research being conducted in Australia. Again, due to the fact that the nature is able to be manipulated, nanotechnology can have impacts on all fields, industry, communications, medicine, technology, and can therefore have a greater influence on society than the computer revolution. Tiny machines can be made that engineer on an atomic level, manipulating atoms and then assembling them to make a desired material with a specific property. We can turn coal into diamonds, iron into gold, water into wine. But why not think bigger? We can control the shape, strength, and a myriad other material properties. Imagine a car that expands the trunk when you're driving to the airport. Imagine a motorbike helmet that became as malleable as cloth when you're off the bike. Windows let in heat during winter and reflect it away during summer. Nanotechnology is now one of the largest growing areas of science, an area of massive potential where solutions to the world's biggest problems, global warming, sustainability, and food security, may be found. Nobel Prize winner Dr. Horst Stormer said that the nanoscale is the first point where we can assemble something. It's not until we start putting atoms together that we can make anything useful. With this dictum in mind, the importance of nanotechnology becomes obvious. We can increase the capability of our technology 100-fold. The road to complete control of the nanoscale, however, is not without its obstacles, not least of which is the development cost of such technology. In addition to this, the question begs to be asked, are we completely sure of how these novel interactions that nanoparticles undergo work? Should we discount the possibility that negative interaction with the humans exist? For many years, there have been fears of sunscreens penetrating to a cellular level and introducing harmful nanoparticles into the bloodstream. While such events could prove to be highly dangerous, a recent report from the Therapeutic Goods Administration dispels this fear. All the more research needed to fully investigate possible adverse effects of nanoparticles. The benefits of nanotechnology, however, far outweigh the demerits. There is no doubt that nanoparticles are worth their weight in gold, the red clumpy aside, and despite the potential dangers, there have been no recorded incidents, and as such, are widely used. We must proceed with caution, however, when it comes to commercial products, and continue to further our understanding through research. Because nanoparticles are the new frontier of science, and there is no stopping science.